Our planet's story stretches back nearly 4.6 billion years, a time span so vast it's almost incomprehensible. It's a journey through epochs of unimaginable change, marked by cataclysmic events and the slow, steady march of geological processes. We begin our exploration in an era called the Hadean Eon, the very dawn of Earth's existence. This is where our planet was still in its infancy. To truly understand Earth's origins, we must travel to a time before rocks had even solidified, before oceans filled the basins, and long before life itself emerged from the primordial soup. The Hadean was a world so extreme, a crucible of geological activity. It earned its name from Hades, the Greek god of the underworld, a fitting moniker for this fiery epoch. Imagine a planet forged in fire, a world constantly reshaped by volcanic eruptions and asteroid impacts. Molten rock flowed freely across the surface, while toxic gases choked the atmosphere, creating a dense and poisonous environment. And relentless cosmic bombardment rained down from the heavens, constantly reshaping the landscape. There are virtually no fossils or clear rock layers that have survived from this time. The geological record is almost entirely erased. Only faint clues, whispers of evidence, and incredibly resilient minerals remain, offering tantalizing glimpses into this distant past. Studying the Hadean is like piecing together a planetary detective story from the faintest whispers of the past, relying on the smallest fragments of evidence. The challenge is immense, requiring innovative techniques and a deep understanding of geological processes. But the reward is profound, understanding our own origins, tracing the very beginnings of the world we inhabit. So let's begin, witnessing the violent birth of our solar system, the chaotic dance of dust and gas that coalesced into planets. We'll see the first drops of water condense and fall upon a hostile world, a crucial step in the planet's evolution. This is the story of how Earth was forged in chaos, a period of intense geological activity and cosmic bombardment. It's about setting the stage for everything to come, the long and complex journey that led to the world we know today. Welcome to the Hadean, the dark, fiery beginning of our world, a time of immense geological upheaval and the very first steps towards habitability. The epic story of Earth, a saga billions of years in the making, begins not with a bang, but with a swirl. It begins in a swirling nebula, a cosmic cloud of gas and dust, a stellar nursery where stars are born and planets take their first breath. This nebula was the leftover material from the sun's own fiery birth, the raw ingredients for a new world. Within this swirling chaos, gravity, the architect of the cosmos, began its work, pulling tiny particles together, forming ever larger clumps of matter, a cosmic construction project. These clumps grew into planetesimals, the building blocks of planets, small rocky bodies hurtling through space. Through countless collisions and mergers, these planetesimals coalesced, eventually forming a growing protoplanet, our early Earth. Each impact, each collision, released immense heat, a cosmic forge shaping the planet. This constant bombardment turned the young planet into a molten sphere, a sea of liquid rock. But the heat wasn't just from external impacts. Radioactive decay deep inside added even more heat, fueling the planet's internal furnace. This internal heat kept the surface incandescent, a glowing testament to the planet's turbulent beginnings. In this completely molten state, a crucial process began to unfold. Heavy metals like iron and nickel, being denser, sank towards the center, drawn by gravity to form Earth's core, the engine room of the planet. Simultaneously, lighter materials like silicates floated upwards, rising to create the mantle and the very first crust. This sorting process, planetary differentiation, gave Earth its distinct layered structure, a core, mantle, and crust, each with its own unique composition. This differentiation also set the stage for plate tectonics and volcanism, powerful forces that continue to shape our planet to this day. Earth was not born fully formed in an instant, a pristine sphere ready for life. Instead, it was built piece by piece, forged in a cosmic crucible of fire and destruction. The result of this violent genesis was a glowing sphere of liquid rock, a far cry from the blue planet we know today. Temperatures soared to thousands of degrees, a hellish landscape of molten lava and volcanic fire. This fiery genesis, this period of intense heat and formation, set the stage for the Hadean Eon, the Earth's infancy. The Hadean Eon, a time defined by extreme heat, constant volcanic activity, and dramatic transformation. The raw materials, the building blocks of our planet, and the internal heat engine that would drive its evolution for our planet's future were now in place, ready to shape the world to come. The Hadean, the dawn of Earth's existence, had truly begun, a fiery beginning to an incredible journey. Picture standing on early Earth, no solid ground, just a vast churning ocean of magma. Temperatures soared above 1,000 degrees Celsius, with convection currents constantly reshaping the surface. The first atmosphere was thick with hydrogen and helium, but solar winds soon stripped it away. Outgassing from molten rock created a new toxic atmosphere: water vapor, carbon dioxide, nitrogen, and sulfur compounds, but almost no oxygen. The sky glowed a murky red or orange, and atmospheric pressure was crushing. This dense, poisonous air trapped heat, keeping the surface molten for millions of years. Life was impossible. The planet was a dynamic, violent furnace. Solid, liquid, and gas states of matter were in constant, dramatic flux. This was the crucible in which the future Earth was being forged. Only after this fiery phase could a more familiar world begin to emerge. The Hadeans' violence extended beyond Earth's surface. The young solar system was a shooting gallery of asteroids and comets, bombarding Earth for hundreds of millions of years. This late heavy bombardment saw city-sized objects slam into the planet, vaporizing crust and lighting the sky with fiery impacts. The most significant collision was with Theia, a Mars-sized body whose debris formed our moon. The moon's creation stabilized Earth's tilt, shaping our climate and tides. These impacts delivered new materials, possibly even the building blocks of life, while keeping the surface molten. The constant bombardment delayed cooling, repeatedly melting any forming crust. Earth was shaped by both internal heat and relentless cosmic violence. The Hadean was a world under siege, its destiny forged by fire from within and above. Only after this chaos could the planet begin to cool and transform. For millions of years, Earth remained a molten world, a seething cauldron of liquid rock. The surface was an incandescent expanse, with temperatures far exceeding anything we can imagine today. Its heat was sustained by relentless impacts from space debris and the ongoing radioactive decay within its core. Asteroids and meteorites bombarded the surface, each collision releasing tremendous energy, while radioactive elements deep within the Earth slowly released their stored heat. Gradually, as the cosmic bombardment lessened and the radioactive heat began to decline, the planet started its long, slow process of cooling. This was a critical transition, a shift from a completely molten state towards a more stable, solid surface. The vast magma ocean, which once covered the entire planet, began to lose its intense heat to the cold vacuum of space. This marked the initial stages of crust formation, a pivotal moment in Earth's geological history. Slowly but surely, the surface cooled enough for the first thin, fragile crust of basaltic rock to form. This nascent crust was a patchwork of solidified lava, a brittle skin stretched across a still molten interior. This early crust was far from stable. It was a dynamic and volatile environment, constantly shifting and reforming. It was constantly fractured by the powerful forces of mantle convection churning beneath, and frequently shattered by the continued, albeit diminishing, impacts from space. Volcanic eruptions were commonplace, tearing through the fragile surface. As the surface cooled, the thick, steamy atmosphere, saturated with water vapor and volcanic gases, began its own transformation. This dense atmosphere played a crucial role in regulating the planet's temperature. It also began to cool, albeit slowly, paving the way for a dramatic shift in Earth's climate. Eventually, as temperatures dropped further, the abundant water vapor in the atmosphere began to condense, forming vast, dark clouds that blanketed the entire planet. And then, the first rain began to fall, a monumental event in Earth's history. This was no gentle rain, but a relentless deluge, an unending torrent of water pouring down upon the scorched landscape. This epic rainfall may have lasted for millions of years, an unimaginable period of constant precipitation. The hot, acidic rain hit the still hot crust, instantly boiling back into steam, creating a thick, swirling mist that enveloped the planet. This water would then rise again, only to fall again in a titanic cycle of evaporation and precipitation. This continuous process accelerated the cooling of the Earth's surface, effectively carrying heat away from the rocks and into the atmosphere. Gradually, as the planet cooled further, water began to accumulate in the lower-lying areas, forming pools and shallow seas. This marked the birth of Earth's hydrosphere, the beginning of the vast network of oceans, lakes, and rivers that cover our planet today. The presence of liquid water was a profound turning point in Earth's history, a critical ingredient for the emergence of life. It set the stage for the complex chemical reactions and biological processes that would eventually lead to the first living organisms. The Hadean world was undergoing a dramatic transformation, slowly transitioning from a realm of fire and brimstone to a world where water reigned supreme. The planet's next chapter, a chapter defined by water and the potential for life, was about to begin. As rain continued and the crust cooled, water pooled in low areas, forming the first lakes and seas. Soon these merged into a global superocean, covering almost the entire planet. There were no continents, just scattered volcanic islands in a vast, dark ocean under a thick, cloudy sky. The early ocean was hot, acidic, and rich in dissolved metals, a murky, greenish brine. Volcanic activity constantly reshaped the seafloor and leached minerals into the water. Despite its alien nature, this ocean stabilized Earth's temperature and provided a medium for chemical reactions. Water's presence was pivotal, moderating climate and enabling the chemistry of life. The fiery Hadean world had become a water world, a planetary cradle for future life. The stage was set for the next great transformation. Studying the Hadean is challenging. Almost all traces of its crust have vanished. But within younger rocks, scientists have found tiny, durable crystals, zircons. Zircons form in cooling magma and trap uranium, which decays into lead at a known rate. By measuring uranium and lead, geologists can date zircons with remarkable accuracy. The oldest zircons, found in Australia's Jack Hills, are up to 4.4 billion years old. These tiny grains are the oldest known materials from Earth's surface. Their chemistry reveals astonishing clues. Oxygen isotopes suggest they formed in the presence of liquid water. This evidence pushes back the timeline for Earth's oceans by hundreds of millions of years. Zircons show that Earth cooled and developed water much earlier than once thought. These crystals are time capsules, offering a rare glimpse into the Hadean world. They reveal a planet evolving faster and more hospitably than we ever imagined. Despite zircon clues, the Hadean remains mysterious, especially the origins of continents and life. When did thick, buoyant continental crust first appear? Did plate tectonics begin in the Hadean or later? Some evidence hints at early continental crust, but this is debated. The formation of continents and tectonics would have transformed Earth's geology and climate, creating new habitats. Could life have begun in the Hadean? Deep-sea hydrothermal vents may have provided safe havens for life's first sparks. The earliest fossils appear later, but chemical hints suggest life may have emerged as early as 4.1 billion years ago. The vanished Hadean world is more than a curiosity. It's the foundation of everything we know. The formation of Earth's core mantle crust atmosphere and oceans set the stage for all that followed. Studying the Hadean helps us understand Earth's cycles, climate, and dynamic evolution. It also guides our search for life on other planets, offering a template for what young, rocky worlds might be like. The Hadean is our origin story, a tale of violence, transformation, and improbable beginnings. Every atom in our bodies, every drop of water traces back to this ancient era. To study the Hadean is to appreciate the epic journey that led to our living world. It connects us to the cosmos and reminds us of our planet's resilience.